All right, so welcome to this class. Okay, so this class we are going to be solving tutorial sheet 1. Okay, so in this specific class we are going to look at tutorial sheet 1 for chemistry 1000. Okay, and I also noticed that you guys for chemistry 1010 you also have a tutorial sheet. Okay, so we are also going to solve that one. Okay, so let me just check my timetable here. When do I have chemistry for Unza? Okay, Wednesday, which is today. Okay, so today we are going to do chemistry tutorial sheet 1 for chemistry 1000. Okay, and then here I have chemistry on Saturday again at Unza. We're going to do the tutorial sheet for 1010. Okay, but the concepts that we are going to learn today will be the same concepts that we apply even in chemistry 1010. Okay, so if you're for 1010, don't leave the meeting. You can still learn. Okay, as well as those who are doing chemistry 1000 on Saturday when we'll be solving the tutorial sheet for 1010, you can also be there because the concepts, they're just the same. Okay, so be free to ask questions if you do not understand anything that I will be explaining. Okay, so this tutorial sheet has about how many questions? Okay, so it has about 11 questions. Okay, for chemistry 1000, we are going to solve all of them. And then I also have this one for 1010. We are going to solve this one on Saturday. I think this one has a lot of questions. Okay, we are also going to try to solve all of these questions here. How many questions? 20 questions. Okay, we are also going to solve all these questions here. Okay, so I encourage you to participate as we'll be looking at this tutorial sheet. Okay, if I explain anything and you do not understand, please feel free to ask. Okay, don't type in the chat box. I won't be able to see your question in the chat box. So just unmute yourself and then ask your question, and then we continue like that. Okay, so don't feel shy. No one is looking at you. Okay, so for those who do not know me, my name is Tutor Post Solutions, and I'm from DISCRETE Learning Institute. We just offer online lessons, okay, for students that are taking NS or pre-med courses, which is math, chemistry, physics, and biology. Okay. All right. So we start from. Is this the first question? Okay. Let me go back here. Yeah, so question 1, they're just instructions here. So we start from question 2, okay? So we start from question 2 there. So on question 2, they're saying, how many significant figures does each of the following contain? Okay, how many significant figures does each of the following contain? So for you to be able to state the number of significant figures, okay, you have to know the rules, okay, on how you can assign significant figures. Okay, so I remember we discussed those rules when we are doing we discussed those rules when we are looking at the units. Okay, on the first part there, we said all non-zero numbers are significant. Okay, so as long as a number is not a zero, it's what? Significant. That's what we said. And then we said we have three types of zeros. Okay, we have the leading zeros, which are the zeros before the non-zero digit. We have the trading zeros, which are the zeros after the non-zero digit. And then we also have the what? The captive zeros. So if I can draw them here, okay, the leading zeros will look something like this. So the zeros that come before a non-zero digit, that's what we say the trading zeros are. And then we add the captive zeros, the zeros that are in between what? Two non-zero digits, okay? And then we also said we have something like this. These are called trading zeros, the zeros that are coming after the non-zero digit, okay? So we said all non-zero digit numbers are significant. And then we said if a zero is a leading zero like the way it is here, okay, we do not consider it as significant. We are not going to count that zero as significant if it's a leading zero, always, okay? Leading zeros are not significant. That's what we said. And then we said captive zeros are always significant, okay? As long as you have two zeros that are between two non-zero numbers, we said all those are going to be counted as significant, okay? And then when we go to the trading zeros, okay? The trading zeros, the zeros after a non-zero digit, we said for those, okay, we said for those, they can be significant and they cannot be significant, okay? So they can only be significant if that number contains a decimal point. Okay, so in this case here, I have 5 and then these 4 zeros. These 4 zeros here are not going to be counted as significant. Why? Because there's no decimal point in this number. But if I wrote something like this, and then I say 0.00, okay, we are going to count these zeros as significant. Why? Because there's a presence of a what? A decimal place, a decimal point, I mean. Okay, so that's the summary of the rules that you need to use. Okay, if you missed that video, you can search it on my YouTube channel. Okay, just search significant figures and scientific notation tutorial solutions. You should be able to come up. Okay, so those are the rules that we are going to be using in answering these questions here. So the first one, they're saying 54. So how many significant figures do we have here? Okay, we're just going to say 2 because these are non-significant, are non-zero numbers. Okay, so we count the 5 as significant and 4 significant. Okay, even this number here, 4, 5, 6, 7, 8, we're going to count all of them. 1, 2, 3, 4, 5. So this number has 5 significant figures. Okay, what about the one there, this one? So 4.03. How many significant figures? We're going to count 1, 2, 3. So we are counting this 0 as significant because it's a captive 0. So this one has 3 significant figures. Okay. What about the number on 4? Okay, on 4 we have 4.00. Okay, we're going to say this number has 3 significant figures. Why? Because there's a decimal point here. So these 2 zeros here are counted as significant. So you have 1, 2, 3 significant figures. Okay. What about this number on 5, which is 400? Okay. This one here, we're going to say it has 1 significant figure. Why? Because there's no decimal point in this number. Okay, so these 2 zeros are considered as not significant. All right, so we continue with 400, and then there's a point at the end there. Okay, so because of this point, we're going to count this 0 and that 0 as what? Significant. Okay, so this number will have 3 significant figures. Okay, what about this one? On is that 7? Okay, so we have 0.041. So how many significant figures does this number have? We're going to say this one has 2 significant figures. Why? Because the leading zeros are never significant. So we're just counting this 4 and this one as our significant what? Figures. So this one has 2. Okay, let me erase this and then we look at the other one there. So the other one is 6500. So we're going to say this one here has how many significant figures? It has 1, 2. These are trading zeros and there's no decimal point anywhere. So we're going to say this one has 2 significant figures. Okay. What about this number? Okay, it is 19090 9090. Okay, so how many significant figures are here? Okay, anyone to try? How many significant figures do you think this number has? Anyone?
Eight.
Okay, someone is saying 8. Okay, let's count. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're going to say 8 significant figure. So we are not counting this 0 as a significant number. Okay, why? Because it's a trading 0. It's at the end and there's no decimal point here. But for these other zeros here, they are captive zeros. They are between what? Non-zero digits. No wonder we are counting them. But this one, no. So we're going to say this number here has 8 significant figures. Okay. And then what about this one here? So 0.00010. So this one only has 2 significant figures, this one and this 0. So this 0 is significant because there's a decimal point here. And then these zeros here are not significant. Why? Because they are leading zeros. So leading zeros are never significant. Okay, so we are done with this first question here. So any question before we move to the next one? All right, so I hope you guys have understood here how we are finding the answers. If you have any questions,
But
please don't hesitate. Someone has a question?
I have a question, sir.
Yes, you can ask.
What if you have 300 grams? How many significant figures are present?
Like this 300 grams.
Yes, yes.
Yeah, so here we are going to get this one here, the 3. So we are going to say we have one significant figure here.
Hello?
Hello?
Yes, can you get me?
Yes, I can get you.
Oh, I read that it was in the manual, that one for physics, if not chemistry. They said if it has got an SI unit, then meaning even the zeros count as significant. So in this case, it has 3.
Okay, so I get what you are saying.
Yes,
Okay, so when you are making the measurements, right? When you are making the measurements, there's the concept of certain and uncertain digit. Okay, so if you get a
I've
number,
heard that.
yes. So if you get a number that has is that has an SI unit, yes, you're going to consider even the zeros. You're going to consider them significant. Why? Because they are important to the magnitude of the number. Okay, if we are
Exactly.
yes, they're important to the magnitude of the number. No wonder we are considering them as significant. Yeah. So we may correct that. So if you are given a number that was measured and then it has SI units, you also count the zeros, even if there's no decimal point there. So you count the zeros there. So that's an exception that you should take note. Yeah. But if it's just given as 300 without the units, just like this, then we are just going to get the we are going to say this one here as one significant figure. And then if it has a unit, okay, which is an SI unit, we are going to count it because it is important given the magnitude of that measurement that you made. All right, so any other question? Okay, so let's look at the next question here. So this is adding numbers that have that have different number of significant figures, or in the other case that you can say that adding numbers that have different number of decimal places. Okay, so what should you use there? So when you are adding two numbers that have different number of decimal places, okay, the rule that you should follow is that the final answer should have the same number of decimal places as the number that had the least number of decimal places. Okay, so for example, if I have 5.1 and then I'm adding 2.001 like this, okay, if I'm adding those. So we are going to say this one here, how many decimal places can you see? It has one decimal place. Let me write it, one decimal place. And then this one here has 3 decimal places. So when we add this number to this number, okay, when we add this number to this number, the final answer that we should get should have one decimal place. Why? Because of the two numbers that we are adding, okay, of the two numbers that we are adding, the number that had the least decimal places had one decimal place. Okay, so it means even the final answer should have one decimal places. So that's the rule that we use when you are adding or subtracting like that. Okay, you use the same rule. So you just get your calculator. Someone has raised their hand. You have a question?
Uh, can you please repeat what you just said? I'm
Okay.
having.
Oh, all right. So I was saying when you're adding or when you're subtracting two numbers that have different number of significant figures, or we can say different number of decimal places, okay? The final answer that you should get should have the same number of decimal places as the number that had the least number of decimal places among the numbers or between the numbers that we are adding. So I was given an example here. I said I have 5.1, and then I say plus, I have 2.001. Okay, so this 5.1 has 1 decimal place, and then this 2.001 has 3 decimal places. So when you add these two, okay, when we add these two, what are we going to get? We're going to get 7.1001. Okay, so this is the I think I've included an extra 0 here. So 7.101 like this. So this is the answer that we're going to get, right? When we just add this. But how do you represent that final answer? You're going to say this final answer should have the same number of decimal places as the one that had the least number of decimal places. So you round it off from there. You're going to say the answer there will be 7.1. Okay, so the answer there will be 7.1. So that's what I was saying there. So that's what we are going to use there. So just be simply adding those numbers, and then we are considering how many decimal places they had. Okay, so on number 1 there we have 55.43 plus 44.333 plus 5.31 plus 9.2. Okay, so this one here, how many decimal places? It has 2 decimal places. This one here has 3 decimal places. This one here has also 2 decimal places. This one here has 1 decimal place. So it means when we add all these, the final answer should have what? 1 decimal place. Okay, so you just get your calculator and then you try to punch those values. So 55.43 plus 44.333 plus 5.31 plus 9.2. Okay, so when I punch that on my calculator, I'm getting this value, 1144.273. Okay, so this is the answer that I'm getting. But remember, the number that had the least number of decimal places had 1 decimal place. So it means we have to round off this number here to have 1 decimal place. So we're going to round it off from here. Yes, Mr. John, you have a question?
Yes, sir. I've got a question.
Yes, you can ask.
Okay, sure. What if so when in a situation, in a scenario where you have been told to calculate something, let's say in chemistry, you have been told to calculate the number of moles of something. Do you have to follow each rule in each and every step? Let's say you want to find the mass. Let's say suppose the question is you're supposed to find the mass first before you go any further. Do you have to follow the rule when finding the mass? Let's say you're multiplying two different you're adding 2 different masses. Do you have to follow the rule for the same decimal places? You take the least one with the shan and you proceed on each step. You have to follow the rule, or only at the last step of your calculation?
Okay, that's a good question. So it would depend on how you approach the question. So if you want to round off there and then you need to follow all these steps at each step. Okay, but if you don't want to round off, you want to round off at the end, then you can round off at the end. So make sure that when you are adding those masses, okay, the sum that you're going to get, don't round it off. Take it just the way it is into the next step, just like that. And then you round off the final answer, okay? But if you want, you can round off at each step. You can round off at each step as well. But that will be tedious for you. So the best thing is just to not round off any number that you get, as long as it's not the final step, okay? You just get it the way it is. You take it to the next step, you solve, and then at the end now, when you find your answer, you can round it off to the required decimal places or the number of significant figures. Yeah.
Thank you very much, sir.
Right. So here we will have to round off this 7 into this 2, right? So 7 is greater than 5. So it means our final answer there on 1 to be 114.3, like this. Okay. So this will be our final answer there. Okay. So we look at the second one. So the second one, we are still following the same rule because there's just addition there. Okay. So what I'm going to do, I'll just punch in these values on the calculator. So the first one has 3 decimal places. The second one has 4 decimal places. And then the last one there has 5 decimal places. So it means our answer should have what? 3 decimal places. So I'll just punch in these values here. Okay. So someone has the question. You can ask as I punch in these values.
Yeah. So on that final answer, you said that the final answer should be 114.3. But according to the rules, it says that when the number which is next to that number you are rounding off to, if it's an even number, you don't add anything.
Come again. What are you saying?
Are you getting me?
Yes, I can get you. What are you saying?
I'm saying that when rounding off,
Mm-hmm.
and that number you are rounding off to, it's when it's greater than 5, you take 1, right?
Mm-hmm.
Add to the previous number, which is next to that number.
Yes.
But when previous number, it's an even number, you don't add 1.
Okay.
So is 2 an even number or
2 is an
an
even
odd?
number. So I get what you're saying. So that rule applies when you're dealing with the 5. That's when you apply that rule. Have you gotten what I said? When you're dealing with the number 5, that's when you can consider if the number that you are rounding off is even or it's odd. So if it's odd, you round off. If it's even, you don't round off, right? So that happens when you're dealing with the 5.
Or just when you are dealing with 5?
Yes, it's specific to the 5, that one.
Right, all right, thanks.
All right. Okay, so when I add all these numbers here on number 2 here, my calculator is showing me 2671.03028. So this is the number that I get. So I have to round off this number to what? To 3 decimal places. So I'm going to round it off from here. We see that 2 is less than 5. So I'm not going to add anything there. So our final answer will be 2671.030. Okay, so this will be our final answer on the second one here. Okay, what about the third one? Okay, so the third one, this guy here has how many decimal places? 1, 2, 3, 4, 5. So it has 5 decimal places. And then what about the other one? It has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 decimal places. Okay, so now let me punch in these guys onto my calculator. I see what I'm going to get. So I have 69.99999 plus 45 point, and then I have 8 fours there. So 4, 4, 4. How many fours? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what I'm getting is this number when I add those two. Okay, I'm getting 115.44444, and then I have 3, and then 444. Okay, so we have to round off this number to how many decimal places? 5. So where is the 5? So 1, 2, 3, 4, 5. So we're going to round it off from here. So if you round off the 4 is less than that less than 5. So we're not going to add anything to these 3. So we're going to say 1, 1, 5 point, and then 4, 4, 4.
I was asking, we are subtracting, but
Oh, we are subtracting. Oh, I never saw the subtraction sign. Okay, if we were adding, this would be our answer. So now let's do subtraction. I thought we are still adding. Okay, subtraction. Okay, so when I subtract, I'm getting this one. So this one, I got it when I added this. So when we're subtracting, I'm going to get 24.55. And then I have another 5. And then 5. Okay, 4 5s, and then I have 4, 5, 5, and then 6 like that. Okay, so there, let's round this number off to 5 decimal places. So 5 decimal places, it means we're going to round it off from here. Okay, so we're rounding off this 5 to this 4. So this 5, it's equal to 5. So we're going to add a 1 to this 4 here. So we're going to say the final answer is 24.5555 and then 5. So this one here will be our final answer there. Okay, so any questions there?
What about that row again, sir? Before we proceed.
Okay, so that rule happens like this. So take note how it happens, right? So for example, if I was rounding off from maybe where, if I was rounding off from here, like that. So it will mean that here I'm rounding off, let me write it here. So 24.555, and then I'm saying I'm rounding off this 5, right? Okay, so let's say this 5 was not even a 5. Let's say it was maybe 3. Okay, so I'm rounding off this 3 to this 5 here. So the number that I'm going to add or subtract, I'm going to add the 1 or add nothing is the 5, right? So that's where the rule applies now. So you take a look at this number here. So is this number even or odd? Okay, so if it's odd, okay, and it's greater than 5, would have to add a 1 to this 5. So the answer would be 24.55 and then 6 if this number was greater than 5. Okay, but in this case it's less than 5. We're going to keep it like the way it is, like that. Okay, and then if it's an even number, for example, it was 24.555. Okay, so this is the 5 that want to add a 1 or add nothing, right? And then there I had maybe 8. Okay, so this is 8. I want to round it off to this 5, but because this is 5, there's that special rule that you talked about. Okay, so this number here is even, so we are not going to add anything to this 5. We are going to say this is the same as 24.555. Yeah, so we are going to say this is our answer here because this number here is what is even. Okay, but I don't think they really follow this rule. Okay, some might follow it, but I don't think they really do. But it's there. So that's how you apply the rule that you are talking about. Okay, so let's look at question 4 now. Okay, so on question 4, someone has a question again? You can ask.
Okay.
It's okay? Oh, okay. So on question 4, they're saying which number in each of the multiplication division problem is the limiting term, and then how many significant figures should the answer of each multiplication or division have? Okay, so there we're just adding. Okay, so here I didn't see this part. Okay, I didn't see this part there. They're saying the limiting term. So the limiting term is just simply the number that has the fewer decimal places. So on number 1 here, the limiting term is this one. Here, the limiting term is that one. Okay, and then here, the limiting term is that one. Okay, so now let's go to question 4 here. So the rule when you are dividing or when you are multiplying is that the final answer should have the same number of significant figures as the number that had the least number of what? Significant figures. Okay, so when you are adding or subtracting, you follow the number of decimal places. Okay, but when you are multiplying or you are dividing, you follow the number of what? Significant figures. So the final answer should have the same number of significant figures as the number that had the least number of significant figures between the two numbers that you are multiplying or dividing. Okay, so when you look at this one here, add 3, 4, 3.4, and then I'm dividing this by 4.337. Okay, so which one can you say is the limiting term here? Because this one on top, it has 4 significant figures. And then even this one down, it also has, this one has 5 significant figures. Okay, so it means the limiting term here will be the one with the fewer significant figures. Okay, So the one with the fewer significant figures will be our limiting term. And then how many significant figures should the answer of each multiplication have? So first of all, we have to divide this on our calculator. Okay, so you just get your calculator and then you punch in those values. So we have 343.4, and then we are dividing with 34.337. Okay, so my calculator is giving me this number. So I'm going to write it, all of it. So 10.00087 36931. Okay, so this is the exact number that I'm seeing on my calculator. And then from there, we have to make this number here to have how many significant figures? 4. Okay, so how can we make this number have 4 significant figures? We're just going to round off from here. Is it going to be 4 if I round it off from there? No, it's going to be 5. So we have to round off from here. Okay, so rounding off this 0 to this 0. So what are we going to get? We're just going to get 10.00. Okay, so this one is significant. And then these trading zeros here, the 3 trading zeros are also significant. Why? Because there's the presence of the what? The decimal point there. So it means this will be our final answer. So our final answer is 4 significant figures, just like the what? The limiting term there. Okay, so any questions there? Okay, let's look at the second one then. So the second one there, we are multiplying, okay, but we are following the same rule. So how many significant figures does this number have? Okay, that number has 1 significant figure because all these here are leading zeros. So leading zeros are never significant. And then what about this number? How many significant figures does it have? Okay, it has 1, 2, 3, 4, 5, 6, 7. It has 7 significant figures. So all the zeros here are significant. Okay, including this 0 at the end, which is a trading 0. Why? Because there's the presence of that decimal point there. Okay, and then these others are just captive zeros. So we are also counting them as what? Significant. So this number has 1 significant figure. This number has 7 significant figures. So when you multiply them, the final answer should have 1 significant figure. Okay, so it means the limiting term will be this same one here with 0.000 until you get your 3 there. Okay, so this will be our limiting term here, simply telling us that our answer should also have 1 significant figure. So what are you going to do? We're just going to punch these values onto our calculator. So we have 0. Okay, so there, how many zeros do I have? I have 3 there, and then 3. Okay, and then 2. So I have 8 zeros. So 0.000000003 there. Okay, so 0.00 that's 3, and then multiplied by 30.03. Okay, and then I also have 0.3, and then I have 0. Okay, so the number that I'm getting is this 0.0000090, then 09. So this is the number that I'm getting. Okay, so remember we said our answer should have the same number of significant figures as the limiting what? Term, or the number that has the less significant figures. So how can we make this number to have 1 significant figure? Anyone who can try? How can we make this number to have 1 significant figure?
That is 0.9.
Come again? I didn't get you.
I mean, we will remain 0.9.
It will remain what?
4.9.
Oh, hey, I can't get you. I think it's network. You are saying?
I mean, 0.
Okay, I can't get him. Anyone who can get him?
He's saying that it should be 0.9.
Should be 0.9. Okay, so for us to achieve what we
But
want
can I give
here.
it a try?
Okay, yeah, you can give it a try before I
I want
come
to
in.
try.
Yeah.
Yeah, I'm thinking taking it into scientific notation, as in rounding it off until the point becomes 9 there.
Yeah, so
9
exactly.
multiplied by 10. Yes.
Exactly. So to achieve our what you want to get here, okay, we need to put this number in scientific what? Notation. Okay, we have to put this number in scientific notation. All right, so it means we have to move that point to the right. Okay, so I'm going to move this point that you are seeing here to the right. So I'll say this point has moved 1, 2, 3, 4, 5, 6, 7, 8. So it has moved 8 steps to the right. So it means the power should be what? Negative. Okay, remember our lesson on scientific notation, we said when you go to the left, the power should be positive. When you go to the right, the power should be negative. So it means the number that I'll get now will be this 9.00, okay? And then I have 9 multiplied by 10 to the power minus 8, okay? But this number, okay, as you can see it here, it has 4 significant figures. So what are we going to do? We're going to round off from there. Okay, if you want, you can round off this 9 to this, and then this to this, and then that to that. Okay, so what you're going to get there will just be 9 times 10 to the power minus 8. Okay, so that number that we got there, this one here, if we want to put it to have one significant figure, okay, it will be something like this. So this one here clearly has one significant figure, but it has the same magnitude as that one. Okay, so any questions there?
Yes, can you come back a little bit just from 9.009 multiplying 10, yes, exponent minus 8. Can you just explain a little bit from there?
Okay, so here when I move this point, okay, we got this guy here that I'm highlighting in blue, right? Okay, and then this number now, the 9.009, okay, I have to round it off such that I only remain with one significant figure. Okay, so how can I do that? Okay, you can do that by 2 processes. You can just ignore whatever is here and just write 9, and then you multiply it by 10 to the power minus 8. Or you can say, let me round off this 9 to this 0. So if you round off the 9 to this 0, you're going to get 9.01, right? If you round off this 9. And then you say, I round off this 1 to the 0. What I'm going to get? I'm going to get 9.0. Then you round off this 0 to the 9, you're just going to get 9. So that's how we moved to this 9 here. Have you gotten it now? No one was asking.
Yes, yes. Yeah, thank you.
All right. So now let's move to question 5. Okay. So question 5 has some conversions. So there you have to know some conversion factors. Okay, you have to know some conversion factors. So some of them I can see they have been given there. But if they have not been given, then you just have to search for them if it's a question from a tutorial sheet. Okay, but if it's the exam or test, they usually give the conversion factor. Okay, if they know that you are going to use it and you cannot dream of the conversion factor, they are going to give you. But those common conversion factors, they won't give you. But if it's something that is very hard to memorize, they can give you that conversion factor to use. So on the cover page, there will be that conversion factor. Okay, and then when you counter a question talking about that, you can use that conversion factor. So for example, here on this question 5, they're saying if your pace on a treadmill is 25 meters per minute, okay? So 25 meters per minute, that indicates speed, okay? So the speed is 65 meters per minute like this. So this is the speed that has been given here. And then they are saying, how many seconds will it take for you to walk a distance of 8,450 feet, okay? 8,450 feet. So it means there for you to find how many seconds, okay? Because this one here, it is the distance. So we can say the distance has been given as 8,450 feet. Okay, and then the speed has been given in terms of the meters and the minutes. So for you to find how many seconds, okay, what are you going to do? You first of all have to convert this distance from the feet. You have to convert it to the words, to the meters, okay? And then once you have your meters, you can calculate the time in minutes, okay? And then once you have your time in minutes, you can convert it to seconds. So you can move like that, or you can just use a direct conversion where you'll be using dimension analysis, okay? But that one usually confuses you guys. So it's better you do it step by step, okay? So the conversion factor for converting from feet to meters is 1 foot, okay, is equals to 0.3048 meters. Okay, so you see, if you've never seen this conversion factor, you can't know it. You can't dream of it. Okay, so such conversion factors can be given on the cover page. Okay, but sometimes they can require you to memorize this. So you'll be on the safer side if you just memorize it. Okay, so just know that 1 foot is equals to 0.3048 meters. So let's convert this feet here, the distance in feet, let's convert it to meters. So we're going to say, what about if I have 8450 feet here? How many meters am I going to have? So you can cross multiply. So this will be x, okay? And then this number multiplied by that, what am I going to get? Okay, so according to my calculator, I'm getting what? Okay, let me just multiply this. Okay, so you can also counter check with your own calculator. So 8450 multiplied by 0.3048. Okay, so what I'm getting is 2575.56 meters. Okay, so this means that this 8,450 feet are the same as this 2575.56 meters. So now we have the distance in meters, we have the speed, okay, in meters per minute, and we want to find the time. Okay, so that time should be in seconds. So the first step, you can first convert it to minutes, okay, and then you get those minutes, you convert them to seconds. So what we are going to do here is that, you know the formula for finding speed, right? From your grade 12, you said speed is equals to the distance divided by the time. That's what we said, okay? So now we want to find this time. So if I make time my subject, to just be the speed multiplied by the distance. So the speed is 65 meters, okay, per minute. And then multiplying it by the distance, what am I going to get? Multiplying it by the distance. Is this formula correct? The units should cancel, but I'm not seeing them canceling there. Okay, so yeah, so I got the wrong subject of the formula here. The units should cancel. So here, when we can put this over 1, then we cross multiply. So t multiplied by s is going to give me st, and then is equals to d. Okay, yeah. And then you divide both sides by the s. So it means time will just be the distance over the speed. So now this is correct. So you can put your distance there. Okay, so the distance is 2575.56. Okay, so this is in meters, and then we are dividing it with the speed, which is 65 meters per minute. Okay, so what is going to happen here is that this meter and this meter will cancel, so we're just going to remain with the minutes. So we're going to say time is equals to, and then punch this value onto your calculator. Okay, so if I punch that value onto my calculator, what am I going to get? So I have 2575.56, and then I'm dividing by 65. Okay, so I'm getting this as my answer, 39.624 minutes. Okay, so notice that here, I'm not rounding off any number that I got here. Okay, I can only round off at the end. Okay, so these will be the minutes that we'll get for the time. And then since we have the time in minutes, we can easily convert it to what? We can easily convert it to seconds. Okay, so we know that 1 minute has how many seconds? 60 seconds. So what about if I have these minutes now? So 39.624 minutes will give me how many seconds? Okay, so cross multiply. x multiplied by that to just be x is equals to, and then this number multiplied by 60. Okay, so 39.624 multiplied by 60. Okay, so that is giving me 2377.44 seconds. Okay, so this here will be my time in seconds. Okay, that will be my time in seconds. So any questions there? Any questions there, guys? Okay, so the other thing there, you should be able to round off the final answer to the least number of significant that you had. So here we had the 80, we had 65 and this distance here. This one has 3 significant figures. This one has 2 significant figures. So it means your final answer here should also have what? 2 significant figures. So if we round off this, we're just going to get 2380 seconds. So this one here will be our correct answer, rounded off to the correct number of what? Significant figures. Okay. All right, let's look at question 6 then. So on question 6, they're saying an injured person loses 0.30 pints of blood. Okay, and then the question now comes, someone has their mic and mute. So we're getting a background from you. So kindly mute yourself. Okay, so if you want to ask a question, just ask, guys. I'm not able to see the chat. Okay, so here they're saying an injured person loses 0.30 pints of blood. How many milliliters of blood would that be? And then here they have given us conversion factors. Okay, so they're saying 2 pints equal 1 quart, and then 1 quart equal 0.95 liters. So it means we have first to convert these pints, okay, to the quarts, and then from the quarts we convert to the liters, and then from the liters we convert to the milliliters. So here I'm going to use an approach that we call as dimension analysis. So what I have here is 0.30 pints, right? Okay, so I'm going to multiply this guy with the conversion factor of pints to quarts. So I'm going to say multiplied by, and then I'm going to draw a line. So the units that you have on top here are the units that you put down here. So it means from this first conversion factor here, okay, I'm going to say 2 pints down here. And then these 2 pints are equivalent to what? 1 quart. Okay, and then from here, I would want to convert the quart that I'll get here, because when I multiply these two here, this pint and this one will cancel. So I'll just remain with a quart, right? Okay, so the next step is to multiply this with the conversion factor of the quart to the liters. So we've been told that 1 quart, okay, is equivalent to 0.95 liters. Okay, so notice that the same thing should be on the opposite side. So here we can say over 1. The pins were up, here they're down. Quarts were up, here they're down. Okay, and then the last step is to multiply by the conversion factor of converting from the liters to the milliliters. Okay, so this one is a very common conversion factor. We know that 1 liter is equals to, okay, 1000 milliliters. Okay, or it can be 1000 cubic centimeters. So milliliters and cubic centimeters are the same. And then the liter is the same as a cubic decimeter, like that. So if you see 1 liter, 1 cubic decimeter, they're just the same. When you see milliliters, cubic centimeters, they're just the same. So don't get confused. Okay, especially when you be doing dealing with the concentrations of solutions. Okay, you are going to encounter different units there. Okay, especially those who are taking chemistry 1010, you're going to encounter different units there. So don't get confused. Okay, so let's now convert the liters to the milliliters. So we're going to multiply by the conversion factor of the liters to the liters. So liters is on top here. Here I'm going to put it down. So I'm going to say 1 liter is equivalent to what? 1000 milliliters. So what we see here is that these pins will cancel. quarts and quarts will cancel, liters and liters will cancel. So what have we remained with? Only the desired units that we want, which is what? Milliliter. So we have 0.30 multiplied by 1 multiplied by 0.95 multiplied by 1000 milliliters. So what are we going to get? So just multiply that number on your calculator. Okay, so let me do that. So I have 0.30 multiplied by, I have 1 multiplied by 0.95, okay, 95, then multiplied by 1000. Okay, so when I multiply all this, I'm getting 285 milliliters. Okay, so that would be my final answer there. So any questions there?
Why didn't you divide
There
by
is
Hello?
One at a time. So the
Yeah.
male one first and then the female.
Why
No, it's
didn't
ladies.
male mono?
At what?
Why didn't you divide by the 2 here?
Yeah,
Oh,
that's my question too.
I just missed it. It's to tell me, Kaide. I just didn't see it. So here we have a
we're
2,
telling
right?
you now. Okay, maybe it was
Oh,
Of
okay, okay.
course.
Yeah, so we have a 2 down there. So it means whatever you get here on top, we're going to divide it by 2. So what we got on top was that thing there. So we're going to say this guy, we divide it by 2. So let me punch this now. So our final answer will be 285 divided by 2. Yeah, so it's giving me 142.5 milliliters. Okay, so I think that one should be okay now. All right, so let's go to question 7 now. Okay, so on question 7, what are they saying? Okay, so question 7, they're saying a sofa has mass 29.3 kg, a refrigerator has mass 112.5 kg, and the lamp has mass 6.25 kg. What is the total mass of all the 3 items rounded off to the correct thing? Yeah, okay. So this is what we are doing on, is it question 3 or question 2? So here we're just adding. So 29.3, we're going to add it to 112.5 plus 6.25. Okay, and then the final answer should be the number that has the same significant figure, the same decimal places, okay, as the one that had the least decimal places. All right, so this one here has 1 decimal place. This one here has 1 decimal place. This one has 2 decimal places. So since we are adding, our final answer should have what? 1 decimal place. Okay, so when I add all this, what is my calculator giving me? Okay. Okay, let me just add them. So I have 29.3 plus 112.5 plus, and then I have 6.25. Okay, so I'm getting 148.05. Okay, so this number here has 2 significant figures. Okay, so it means we have, I mean, it has 2 decimal places here. So we have to round off so that we have only 1 decimal place. So we're going to round off from here. So this 5, we round it off to the 0. We are going to get 148.1. Okay, so this will be kg. So this here will be our final answer, rounded off to the correct number of significant figures. Okay, so the secret here is to making sure that the different masses that you are adding, okay, have the same units. Okay, so this is kg, this is kg, this is kg. So we have no problem there. But in most cases, okay, when they are giving you questions, they will give you quantities that are in different units. Okay, so you can't add units unless they are of the same units, like they are like these ones here, they are all in kg, so we can add them, no problem. But if they give you in different units, okay, let's say some of them they are in grams, others are in milligrams, okay, you have to convert all the units to a common unit, okay, and then once we have all the quantities in the common units, you can now add them. Okay, so always make sure that the units are the same. You can't add a banana to an apple. Okay, you can't. So you have to make sure it's uniform. Okay, so take note of that. That might be a question that may come. Okay, and then this other question on question 8 here is your grade 12 question. This is just density. So they are saying what here? A cough syrup has a density of 0.959 grams per cubic centimeter. And then calculate the volume if the mass is 50.0 grams. Okay, so we know that density is equals to what? Mass over volume. So we're calculating the volume. So if we make volume the subject, to just be mass over what? The density. So this will be equals to, okay, so we divide the mass with the density. So the mass is 50.0 divided by the density, which is 0.959. Okay, so when we divide this, what are we going to get? Okay, so if I punch on my calculator, I'm getting this 52.14 cubic centimeters. This is my volume, okay? But here we have to consider the number of significant figures. So this one has 3, this one has 3. It means even our answer should have what? 3. So we're going to round this guy off from there. So round off this 4 to the 1. So it means our final answer will just be 52.1 cubic centimeters. So this is our answer there. So any questions there? Okay, I hope there are no questions there because you guys, okay, you guys are okay with this. Okay, let's go to question 9. So question 9 has something interesting. Okay, something very simple, but sometimes it can confuse you students. Okay, so when you are given an element from the periodic table, okay, so that element is usually represented as a nuclide. Okay, so it means you have the chemical symbol there, and then you have a certain number there, and then a certain number there. Okay, so depending on the model of the periodic table that you are using, okay, these numbers here, they can mean the different thing. Okay, but there are just two things involved. But depending on the key of that periodic table that you are using, okay, it will depend what they will mean. So usually, okay, usually the number on top here indicates the atomic number. Okay, so this would depend on the periodic table that you are using. If that's the key that they are using, okay, they are saying the number on top of the symbol is the atomic number, you follow that. Okay, and then it means that the other number would just be the what? The mass number. Okay, so on some periodic tables, we have the mass number on top and then the atomic number below there. Okay, so what is the atomic number? So the atomic number is simply the number of what? Protons. So these protons are positive in nature. Okay, the number of protons is the atomic number. So the unique thing about the proton number is that, okay, the unique thing about the proton number is that it gives you the identity of the element. Okay, no two elements can have the same proton number. Okay, it will never happen. So the proton number gives the identity of the element. Okay, or it gives us it helps us find the name of that element from the periodic table. Okay, because when they say the proton number, okay, of a certain atom is 8, okay, no matter how many electrons it has or neutrons it has, that atom will always be oxygen. Okay, why? Because it has 8 protons. Okay, so anything that has 8 protons, it's oxygen. Okay, regardless number of the nucleotides, I mean the neutrons and the electrons. Okay, as long as it has 8 protons, that one will be oxygen. So the proton number gives the identity of the what? Of the element. And the protons in the element, they do not move. Okay, they do not move. They are just constant. They are just there. They're giving that element its identity. Okay, so that's what the atomic number is. And then this mass number here is the sum of the protons plus the neutrons. Okay, so the neutrons have a neutral charge. They have no charge. Okay, their charge is what? 0. Okay, so what's the unique thing about the neutrons? The neutrons, they contribute to the mass of the atom. Okay, the neutrons contribute to the mass of the atom. Remember from that structure that we are drawing at grade 12, you said in the nucleus, you're going to find the protons, which are positive, and these neutrons, right? Okay, and then in the shells around them, okay, very soon you are going to stop calling these things shells here. They will no longer be shells. Okay, they will no longer be shells. You have orbitals and all other things. So we said these neutrons, okay, are found in the nucleus there. So their main thing that they do in an element, the neutrons, okay, they contribute to the mass of the atom. So the neutron number can change. Okay, someone has their mic unmute. Let me just mute them. So I'm saying the neutron number can change. Okay, so if the neutron number changes, that's where we get our isotopes from. Remember how you were defining the isotopes? We said isotopes, atoms of the same element, but have different mass number or have different neutron number or number of neutrons. Okay, that's where we're getting it from. So the neutrons can change, okay? Can change. Their number can change. So when the number changes of the neutron, we get the isotopes, okay? So its main contribution of these neutrons is just what? The mass of the atom, okay? And then we have the other ones, which are what? Electrons. So these guys are very important. So electrons have a negative charge. So the electrons, okay, are responsible for the chemical reaction or chemical interaction of that element with any other element. Okay, no wonder they are found in these shells here. No wonder we're seeing them in these shells here, so that they can easily react with another element here, which also has an what? An electron there. They can react. So that's their main job, to react and cause a chemical reaction. Okay, so these electrons can move. Okay, so an atom, if it loses electrons, it becomes a positively charged ions. Okay, it becomes a positively charged ion. And then if it gains electrons, okay, it becomes a negatively charged what? Ion. So when it gains electron, it means it has gained extra negative charges. No wonder it's becoming negative. But when it loses electrons, okay, it has lost the electrons that made it to be in a neutral state. No wonder it's becoming what? Positive, okay? But the key thing that you should know is that in a neutral element or a neutral atom, the number of electrons and the number of protons, they are always equal. As long as that element is neutral, it has no charge, okay? The number of protons and electrons is always equal. Okay, so when they ask you how many protons are in this element, okay, if that element is neutral, just know that even the number of electrons is the what? Is the same. Okay, so I've explained here, I said you have a chemical symbol and then two numbers above and below here. Okay, so this one can be the atomic number, that one can be the mass number. And in other periodic tables, okay, you have the mass number on top and then the atomic number down. Okay, but how? But now, how do you know? Okay, in case you are given something like we have been given there, how do you know which one is the atomic number, which one is the mass number? Okay, so the smaller number is always the atomic number. Okay, the smaller number of the two numbers that are above and below an element is always the atomic number. So here we've been given this X, and then on top we have 226, and then here 88. So it means this one here, this bigger number is the mass number, okay? And then this smaller number is always the atomic number, okay? So that's how you can know that, okay, this one is the atomic number, that one is the mass number, if you're not given a key. So this one is the atomic number. So now answering this question, they're saying, what is the number of protons? Number of protons will just be 88. Okay, 88. And then number of electrons will be the same as protons because this atom is neutral, there is no charge. And then what about the the neutrons, I mean? So the neutrons you subtract, okay? The mass number, which is 226 minus the proton number. So what are you going to get there? Okay, when I subtract there, I'm getting 138. So 138 is the number of what? the number of neutrons. Okay, and then B, they're saying identify the element. So how are you going to identify this element X? You're going to go on your periodic table, and then you look for an element that has the proton number of what? 88. Remember, we said the proton number gives the identity, right? Okay, so if I can go to my periodic table here, I hope you'll be able to see it. Okay, I hope you are seeing the periodic table here. So this periodic table, according to its key, on top we have the atomic number, down there we have the atomic mass, okay, or the mass number. So it means I'm looking for an element that has 88. So should be this one here. Okay, let me just zoom in there. So 88 is this one. This guy here is the one that has 88. This one here. You can see that on top there, it has 88 as the what? The proton number. Okay, so we have identified it. It means that one is just what? Rubidium, like this. Okay, that would be the name of that X there. Okay, so this X here will just be what? Rubidium there. All right, so any questions here? All right, I think that is straightforward. We go to question 10 and then question 11. I think that's the last question. So question 10, they're saying the atomic weight of copper is 63.546. Okay, so the atomic weight of copper is this. This is the same as the relative atomic mass. Okay, or you can say the average atomic mass. So the average atomic mass is 63.546. Okay, atomic mass units. And then they're saying two naturally occurring isotopes of this copper have the masses. Okay, so we have copper 63. Okay, copper 63 with the mass 62.9298 atomic mass units. And then we also have copper 65. So copper 65, which has the 64.9278 atomic mass units. Okay, so this is what we have. Okay, so now what's the question? So the question they're saying calculate the percentage abundance of copper 63. Okay, so how are we going to calculate that? So we have to use that formula for relative atomic mass when you have two isotopes or more of the same atom. Okay, so that formula states that the relative atomic mass or the average atomic mass or the atomic weight, okay, is just equals to the percentage of that isotope. So we can say isotope A multiplied by, okay, the mass of isotope A. And then we are going to say plus the percentage of another isotope, let's say isotope B, multiplied by the mass of isotope what? B. So in this question, we want to find these percentages here. Okay, we want to find these percentages here because these masses have been given. So this is the first mass, this is the second mass. So even this RAM has been given. So we are going to say that, okay, let the percent of copper 63 be X, and then the percent of copper 65 be Y. Okay, so we know that the two percentages should add to what? Should add up to 100. So we are going to say here, X plus Y should give me what? 100. Okay, and then let's try to replace these numbers into the formula. So the RAM is this. So I'm going to say 63.546 is equals to the percent of copper 63. I'm going to write X multiplied by, and then, okay, X multiplied by, and then the mass of copper 63 is 62.9298, and then plus, okay. So this percent here, remember the percent is always over 100, right? So we should put this percent over 100, okay, because this is X percent, this is X percent, so it should give us 100%. Okay, so I'm putting X over 100 because X is, I'm taking it as a percent there, okay? And then even on the other side, we have the percent for this copper 65, which is Y percent. So Y over 100, and then what else now? Y over 100, and then multiplied by the mass here, which is 64.9298. 9278. Okay, so this is the equation that I have. So I want to find my x here and this y. Okay, so how can I do that? So I'm going to erase the top part here. So what we're going to do is that on the left-hand side, we still have 63.546 is equals to. And then here, I have x of 100 multiplied by this. So that is the same as 100 divided into this, and then I multiply by x. So what am I going to get there? Okay, so you can patch that on your calculator. So that would be the same as 62.9298 divided by 100. Okay, so I'm going to get there 0.629 and then 298x. Okay, and then I'm going to say plus. On the other side, it's the same. I'm dividing this by 100 and then I'm multiplying by y. So I have 64.9278 divided by 100. So I'm getting 0.64 and then 9278y. Okay, so from there now, we want to solve for x and y. Okay, so we have two variables here. So it means we need to have two equations. So this here is the first equation. The other equation is this one. Okay, so from this equation here, we are going to get the value of y. So we can make the y the subject of the formula there. We're going to say y is equals to 100 minus what? X. Okay, so it means wherever there's y, we're going to put 100 minus x. So this becomes 63.546 is equals to 0.62928 x plus, okay, and then where there's y here, we're going to put 100 minus x. So I have plus, okay, I'll just write it below here. So I have plus, and then this one, I'm going to say 0.649278. And then where there's y there, I'm putting 100 minus x. Okay, I hope you've seen what I've done there. Okay, and then from there, we can continue. So 63.546 is equals to, this one is the same. Okay, and then here we are going to multiply now. So this number here, multiplied by 100, we're just moving this point 1, 2. So I'm going to get plus 64.9, 64.9278. Okay, and then this number multiplied by minus x, I'm going to get minus 0.649278. So this is what I'm going to get. Okay, this one has an x at the end. So here we're just going to put like terms together. So those without the x, okay, they go together. Those with the x, they also come together. So it means we are going to have 63.546. This guy here will move to the left-hand side, so it will be minus 64.9278 is equals to, and then here I have this 0.629298x, and then minus this guy here, so 0.649278x. Okay, so let's punch these values into the calculator. So the first one there is 63.546 minus 64, minus 64.9278. So I'm going to get minus 1.3818 is equals to, and then on the other side, I have 0.629298 minus 0.6492 and then 78. So here I'm getting minus 0.01998x. Okay, so from there now I can find my x, right? Okay, so I'm just going to divide both sides by this number. So I'll divide this by 0.01998. Even on the other side, minus 0.01998. So it means x will just be equals to, this will cancel each other, and then we can punch this on the calculator. So we have 1.3 818 divided by 0.01998. Okay, so I'm getting 159. Okay, so this number continues to go. So it means the percentage abundance, okay, the percentage abundance of copper 63 is just this guy here. Okay, so we can round this guy to which one at the lowest number of significant figures. So this one has about 6. This one has 5. So we can make this one to have 5 significant figures. We're going to round it from there. Okay, so it means we're going to have x equals to 69.159%. So this will be the percentage abundance, okay, for copper 63. And then what about the other one, which is copper 65? So remember that equation we said y was just equals to 100 minus x. So x is 69.159. So we subtract there, okay? So we are going to have 100 minus 69.159. Okay, so there I'm going to have 30.844%. Okay, so this is the percentage abundance for copper 65. This is the percentage abundance for copper 63. All right, so that is the question 10 there. So any questions there? Okay, and then we can look at the last question, which is question 11. So question 11 it's so simple, okay? So question 11, they're just saying explain the difference between accuracy and precision in measurement, okay? So accuracy, we said it refers to how close a measurement is to the actual true value, okay? And then precision, we said it refers to how close several measurements are to each other and not necessarily the true value. That's what we said, okay? So I even drew like a diagram, I remember. So if this is like a diagram for playing those two darts, okay? And then this is the point that you want to hit. If all your two darts are hitting somewhere there, just near this spot like that, okay? We're going to say this scenario, they are both accurate and precise. Why? Because one, they are hitting just closer to the same target there that you are targeting, okay? And then two, they are closer together like that, okay? And then we can have another scenario. So this is the point we are supposed to hit, but maybe your two darts are just hitting here like that, okay? So this scenario, we're going to say they are precise, okay? Why? Because they are close together. But they are not accurate because they are far away from the what? The target there. Okay, that's what we said. And then we can also have a situation. Okay, this is the target, and then this one hits here, that one hits there, that one hits there, that one hits there. So here they are scattered around. Okay, they're not closer together. They are also not close to the target. So we are going to say that result is not accurate and it's not what? It's not precise. So that's the difference between accuracy and what? And precision. So we are done with this tutorial sheet. Unless you have any questions, you are free to ask. Anyone who has a question? Someone has a question? I can't get you. Your network is breaking.
But I didn't understand.
I didn't get your question. You are breaking. You are saying what?
Yes, sir. Question 10. Sir, there's
Someone who has gotten what she's saying? Okay, I think you can inbox me for your question because I can't get you. So you can inbox me after the class and then I'll be able to help you. Okay, so Chisanga, you have raised your hand.
Yes, please. I was asking
please go back to finding the percent abundance of copper 63 because I was cut off.
Okay, so these are percentages that we found. So I'm going to share this video. So if you missed that part, you can just watch the video that I'm going to share. Okay, I'm going to share it like after the class. Yeah, so we are done with this tutorial sheet. So it means on is it Saturday where we have chemistry? Okay, on Saturday we are going to look at this tutorial sheet for chemistry 1010. Okay, so the concepts that we learn here, okay, can still be applied in chemistry 1000. Just like the concept that we learned in 1000 can be applied here. So you can see here they're also saying state how many and underline the significant zero. The same thing that we are talking about. Okay, so make sure you don't miss that class. Mr. Mlenga, you have a question? Okay, there's their hand. I thought they had a question. All right, so that's it for today. And then, okay, I want to show you guys our website. So you can register with us and you'll be able to access all these courses here. So we have videos on recorded topics. We have videos on recorded tutorial sheets. We have videos on recorded past papers. Okay, so if you'd like to register with us, you can just register there. So for example, if you open this course for chemistry, okay, you're going to go to general chemistry here. And then once you are here, you're going to find lessons and tutorials. So that's where we have the topic lessons, okay, the videos, the notes, everything that you need to know. And then we also have handwritten notes here, very simplified, very explained. You can read them to understand concepts. And then here we have the tutorial sheets. There we have the past quiz, test, and exam papers. Here we have the lab report samples. Okay, so for example, if you go to the lessons and tutorials, what are you going to find? Okay, you're going to find different topics that you're going to have in chemistry. Okay, so all the topics that you're going to cover in chemistry are here. So you just choose whatever you want to learn about. Okay, so for example, if you want to learn about, let me say, maybe balancing equations, limiting reactants, okay, when you go there, you find the notes here. Okay, so if you go there on the notes, you're going to find the notes here. So you can read the notes here to understand the concepts, okay? If you don't want the notes, you want the videos, okay, you can go to the recorded tutorials. So these are videos that are recorded by us. So you can find some videos there you can watch, you can learn at your own time. And then we also have this supplementary tutorials folder. So when you go there, you're going to find some supplementary tutorials based on the same topic. Okay, so we have a lot of videos that can help you learn. And then, yeah, when you pay for a subscription, in the same subscription, we're going to be solving past papers. We're going to be helping you with assignments, okay? Because very soon you are going to be given an assignment in chemistry, okay? So that assignment, you have to answer all the questions and you have to submit, okay, for marking. It will be part of your CA. So tutorial sheets, I can show you here what we have. So when you go here, you'll find different universities. Okay, so you go to your university, which is UNZA. Yes, you can ask your question. You can go to the video solutions. You can also go to the written solutions. So written
How do
solutions.
I pay, like, if I want to register?
Okay, I'm going to talk about that. So these are the tutorial sheet solutions for the previous intakes. So even for you guys, we are also going to create a folder where we'll be putting the 2025 tutorial sheets. Okay, so you can use all this to learn. Okay, so if now you want to subscribe, okay, so you just go on Google and then you type in discrete learning discretelearning.com. Okay, and then when it will take you to the login page. Okay, if you have an account already, you just go on and register. Okay, but if you do not have an account, you first create an account on our website. Okay, and then you pay for whatever courses that you want to pay for. So I'm going to share a video on how you can do that. I'm going to share a registration guide in the group just after the class. All right, so Thank you so much for attending and have a blessed night.
Thank you, sir.